Hello dear friends, welcome to What Shukhov did meeting. Here we'll have a brief look who was our outstanding countryman, excellent engineer and architect, famous science performer, one of the top person of technical media, whom our high school is named after, Vladimir Shukhov. Shukhov's fields of interest were all around the technical challenges of his epoch, and his engineering heritage is still significant and appreciated by even contemporary engineer society. Shukhov had all his professional life been with civil engineering, while also had a numerous successful projects in transportations, chemical technologies, energetics and economics as well, because his motto was to make things better and cheaper both. Shukhov started think creative in the age of schoolhood. Being a pupil of 4th grade, at the age of 13, he proved the famous Pythagorean theorem by means of brand new self-made proof. Pythagorean theorem have been well known all the time. In rectangular triangle, the square of hypotenuse is sum of squares of sides. Shukhov put on some same triangles around, so that there was a central square hole. It came now, the area of red square is c in second power, area of orange hole is a minus b in second power, and area of single blue triangle is half of a on b. It's clear. The red square consists of orange one and 4 blue triangles, and nothing more indeed. Thus, their areas are the members of equation, and have been the unbeatable theorem proof. Funny, but Jan Shukhov didn't took a top mark for this proof, because haven't mentioned the scientists who proved this theorem before him, and teacher thought he's not full enough of respect to the math. First glory of outstanding engineer and inventor reached Shukhov after his invention in steam power and steam energetics. End of the 9th century was a time of great steam. Steam was all over. All the machines were driven by steam. Steam was the blood of economy, and steam efficiency and safety were among biggest challenges of epoch. Steam was ever there was movement and production, mostly in the transport of the already immense Russia, mainly in the railways. The muscle of any steam engine is a steam boiler. It's mainly not much different from those in which we heat water and cook food. Boiling water evaporates, increasing in volume and doing the work of moving the moving part of the machine. An industrial or transport boiler was just an enlarged replica of a domestic boiler, divided by internal bulkheads. However, steam was a very dangerous companion of industrial man. Boilers often exploded, causing enormous economic damage. Shukhov created, patented, and repeatedly reproduced in various formats his own design of a steam tube industrial boiler, which is distinguished by exceptional performance, safety, ease of maintenance, and the ability to increase the machine's power by installing a different number of standard modules, tube bundles. These provided the country with the necessary groundwork for mass industrialization during the Industrial Revolution. The end of the 9th century is a time when oil and oil products were only being mastered by mankind, and only in the long prospects will come the cornerstones of the world economy. Russia nowadays is an industrial giant and an innovator in oil production and refining, but this wasn't always the case. During the time of Shukhov, oil was extracted and used in the most environmentally brutal and ineffective way. The country was a source of cheap oil pouring into the economies of leading European countries. Shukhov made a number of remarkable inventions, simple and efficient, which determined the guidelines of oil industry for decades. Looking at a natural geyser streaming out of the ground and figuring out the physical principles of its picturesque functioning, Shukhov proposed creating a man-made geyser, also known as an airlift. Airlift was made right in an oil well by pumping air into it. Oil inside the well is coming lighter with dissolved air and poops up from the well. That significantly reduced the efficiency and cost of heavy manual oil pumping. Having made oil production cheaper and more simple, Shukhov started thinking of efficiency of oil transportation. Oil was transported to ports, there it was sorted out by foreign ships and sent around the world using primitive containers and horse-drawn wagons. Shukhov proposed a very efficient pipeline, which consisted of united parts what easily repeated the shape of any landscape surface and combined directly at the ground. This pipeline made it possible to highly reduce oil losses and environmental threats, and to increase the speed and productivity of its transportation by dozens of times. Nowadays, pipelines still implement the same principles and design approaches what were set and firstly applied by Shukhov. Having solved the problem of efficiently transporting oil, Shukhov, with grace and perfection, began to study and improve oil storage technologies, which were very imperfect at that time. Oil is stored in tanks, huge cylindrical cans made of thin steel plates. Shukhov conceived to make these tanks lighter and cheaper, and suggested, since he knew well the pressure difference on the top and at the bottom of the tank, to make the thickness and weight of the tank variable. The tank thickness came thinner from the bottom to the roof by assembling from a different number of steel plates. At the bottom, the wall of the tank was combined from several plates, and with the height less and less, up to one at the very top. The variable wall thickness became a breakthrough in the engineering of that time, highly facilitated and cheapened the construction of the tank, and finally allowed Russian manufacturers to offer the market a closed cycle of oil refining and storage. Modern oil tanks are made according to the same principles, only they are much larger, and welding came instead the riveting. The main refinery products of Shukhov time were fuel oil, a liquid fuel used, among other things, in boilers, the engines of the industry and economy of that time. Conventionally burned fuel oil burns very effectively with a lot of pungent black smoke, but extremely inefficient in terms of the combustion energy received. Shukhov began to think about how to improve the combustion process so that it becomes as high calorie as possible. After studying the combustion process from the inside and realizing what the burning of a drop of fuel occurs on its surface, while the volume of fuel enclosed inside simply poisons the atmosphere, Shukhov realized what it is necessary and sufficient to reduce the diameter of the drop by aerating the burning fuel oil using a special device which he suggested. This device is well known to everyone nowadays. It's a sprayer, called by Shukhov as a high-pressure nozzle. The fuel oil sprayed by the nozzle began to burn extremely efficiently with a high-calorie and smokeless way. This invention of Shukhov is among the top of his engineering innovation what have transformed the global industry. Famous Russian chemical and industrial Dmitry Mendeleev, as a token of gratitude for Shukhov's merits, even placed an image of his nozzle as an industrial symbol of his time on the cover of his multi-volume Fundamentals of Production Industry. But nevertheless, the main achievement of Shukhov in the oil industry is not considered to be an airlift, not a pipeline, and not even a nozzle. Shukhov is the author and pioneer of the global industry of complex oil refining into petroleum products by means of its splitting or cracking. Shukhov was the first to carry out the cracking of oil in an ingenious but extremely reliable and efficient device specially created by him, an oil distillation tower. It is a huge steel cylinder at the bottom of which oil heated to a vaporous state and rises upward or sublimes. Heated oil stratifies along the way into compounds of different densities, each settling on its own floor along the height of the tower. Heavy gas oil, diesel fuel, kerosene, and the lightest and most flammable gasoline, all the oil refining products necessary for the industry, were now obtained with minimum cost and maximum productivity. The oil refining technology proposed by Shukhov determined for many decades the directions of the oil industry, becoming the basic oil technology throughout the planet. Modern refineries, the most complex and technologically advanced engineering creations, are unimaginable in scale, but still only quantitatively replicated and slightly improved copies of Shukhov distillation tower. The leader of the Russian oil industry, the company of Lukoil, has installed a monument to Vladimir Shukhov and his oil field inventions near the headquarters on Sretinsky Boulevard in Moscow. But nevertheless, the pinnacle of a career and the accumulation of most significant Shukhov's works is in architecture and civil engineering. The unique, large-spanned and high-rised construction even to this day exciting visitors and owners of these buildings. Shukhov's translucent roof structures, proposed to cover the shopping mall of the most fashionable store in the country of that time, the Moscow Guman Red Square, is distinguished by its exceptional simplicity and grace. Been to Moscow, go there and take a look upwards. You will face with stunning specimen of architectural grace and practice. The biggest challenge in building vaults was to contain horizontal forces at the base of the vault and preventing the walls from collapsing. Creating a translucent ceiling, Shukhov skillfully balanced between two, which seemed mismatching, building principles underlying the construction of vaults. Either thick walls what restrains damages to walls by loading, or a high pointed vault, beautiful but extremely ineffective in the purposes of sunny retail space. Shukhov suggested an innovative solution, a thin steel arc on thin walls, with a completely invisible tightening, a thin steel string stretched between the arc supports. The thin but strong tightening prevented the arc from collapsing, maintaining its preferred cylindrical shape. This incredibly beautiful and engineering structure proposed by Shukhov determined the appearance not only of GUM, but also of many public spaces of that time. All stylish and fashionable Moscow of the 9th century dreamed of decorating its interiors with light and graceful roof designed by Shukhov. But Shukhov wouldn't have been himself if he hadn't even more enriched his engineering heritage with lattice shells. To give the covering of large open public spaces, exhibitions, fairs, industrial premises of exceptional simplicity, ease and reliability in work, Shukhov proposed the creation of a dome downside, a concave shelf inside the volume of the building, all elements of which were stretched, that is, they are in the most favorable state for safety and durability of the structure. These shells were able to install extremely quickly and accurately, even using the most primitive technologies and assembly equipment of 9th century, simply due to the reliability potential embedded by Shukhov. Shukhov's lattice shell are undoubtedly the purest example of the engineering genius, inspired and still inspire a considerable number of architects, including the most eminent and fruitful. The author of numerous masterpieces of modern architecture, British Norman Foster, considers Shukhov to be his creative idol. Michael Hopkins, Ken Shuttleworth, and Human Pay adopt and use throughout their works many of the ideas and inventions of our outstanding countrymen. If you ask the simplest man in the street about what the name of Shukhov is connected with in his mind, then the answer is likely to be the Shukhov Lattice Tower in Moscow. Today, according to Shukhov's principles of lattice towers, hundreds of towers have been installed and still are installing throughout the planet. But this wasn't always the case. Even famous Eiffel Tower in Paris, an outstanding masterpiece of engineering and architecture, was triple more massive than it could be, and Shukhov unbeatable proved it with his towers. Having conceived to create a structurally perfect tower, Shukhov set the main requirements for such a structure: the ability to carry a large vertical load and withstand strong, often destructive horizontal winds. Geometrically, the surface of such an ideal structure is a hyperboloid figure with outlines smoothly varying along height and described by a complex mathematical equation. It worth mentioned you can see it while compressive testing the concrete cylindrical specimens. Fine and solid concrete destructs along this hyperbolic shape. Shukhov, as an excellent geometer, had a brilliant idea of constructive way to create this complex special surface. He applied the simplest, most reliable and accessible way to do this, sliding a linear generatrix along a circular guide. A slight inclination of such a line made it possible to easily transform a simple cylindrical surface into a complex hyperbolic surface of any shape. Having neither modern computers nor computational programs, Shukhov was able for the first time in world engineering practice, relying only on his own knowledge and talent, to calculate the angle of inclination of the line, which makes it possible to create the most simple to assemble and reliable hyperboloid of any size and height. Installing hyperbolic towers already in the Soviet, post-revolutionary, technologically depressive and resource-poor Russia, the builders, led by Shukhov, built structures of record size and strength, most of which are still safe after 100 years of flawless operation and the destructive action of nature. Hyperbolic towers of Shukhov, along with his lattice shells, are the creative guidelines of numerous architectural and engineering schools of the planet. Europe, Asia, the Middle East, many significant for their countries and even record-breaking high-rise buildings of the planet, clearly embodied the principles of optimal high-rise construction initially proposed by Shukhov. Vladimir Shukhov, that he and his heritage. That's all about our famous countryman, an outstanding engineer and architect, academician, whose name is the leading technological university of Belgrade region and the Belgrade airport named after, and to whom monuments have been erected all over the country, and whose endless and impeccable creative heritage is actively and universally used by the real estate market, even in our modern digital age. Think like Shukhov, do like him, and be professional. Thank you.